if you're, you know, if you want to share it with people in Lebanon, I guess, or
Yeah.
wherever.
And the whole Middle East now.
Sorry?
It's the whole Middle East now, and Lebanon.
Yeah, there you go.
Stops now.
There you go. Okay. Are you on?
We're ready?
Are you
We're
ready?
on.
I'm ready. Okay, so welcome to the potential difference ReGenX generator and BiTT toroid transformer demonstration. What we're going to be demonstrating today is the US patented ReGenX generator and BiTT toroid transformer innovations. We're going to basically break up the demonstration into 6 or 7 parts depending. And the first part is we're going to introduce generator armature reaction, which is also called motor action in a generator, and also known in electric vehicles as regenerative braking. And generator armature reaction is explained in a law of physics, Newton's third law, Lenz's law, and the law of conservation of energy. So generator armature reaction is basically a counter electromagnetic torque that's produced inside a generator that causes the generator to require additional input power from the prime mover. Generator armature reaction is the reason why the diesel generators in Lebanon are producing so much pollution, why electricity costs so much, and it's a huge problem. So then we're going to introduce the ReGenX generator, and we're going to introduce the ReGenX generator's load current delay. We're going to do that on the oscilloscope. And we're going to introduce electric vehicle regenerative acceleration. So when we reverse or eliminate motor action in a generator or generator armature reaction, we actually produce a generator that operates at infinite efficiency. And I'm going to explain what that means in concrete terms. Basically, what infinite efficiency performance means is that the generator does not require additional mechanical input power when it's placed on load. So, and we have 4 prototypes that are all going to show that. So basically what that means is if you have a 1 megawatt generator that's delivering a megawatt to the grid, you need a minimum of 1 megawatt or 1 million watts of mechanical input power driving that generator. And because of generator armature reaction. So what we're doing with our innovation is we're taking generator armature reaction out of the equation, and that basically allows that generator to operate at infinite efficiency. And what it means for all future generators, wind turbines, diesel generators, and so on, electric power generation can be provided with 0 watts of mechanical input power. So again, a conventional 1 megawatt generator is going to require a minimum of 1 million watts on the input if it's generating 1 million watts on the output. A ReGenX generator requires 0 watts on the input while it's generating 1 million watts on the output. And I'm going to show you how that's done. Okay, this is the point of you being here, is we're going to show you how that's done. And everything comes back to the load current delay. And in part 3, I'm going to show you how we reverse generator armature reaction, how we get the generator to operate at infinite efficiency, and then what you're going to see at least 4 times, I think, 3 times, you're going to see a generator that generates electricity with no increase in the prime mover input. So no increase in the prime mover input and no increase in the mechanical drive shaft power in the drive shaft. So the diesel generators in Lebanon that are currently producing millions of tons worth of pollution will be able to generate electricity with less consumption than they would use on idle, and 0 watts of mechanical input power. So sounds crazy, but by the time you're done here today, you ought to be convinced of that. So the 4th part of the demonstration is to basically impress on Paul that the technology is commercialization ready. We currently have ReGenX generator coils that can deliver between 100 and 100 amps of current, 60 and 100 watts per coil, and we now have the formula where we can scale up to basically any size. And then we're going to introduce the electric vehicle regenerative acceleration integration, and basically what this aspect of the innovation implies is the elimination of electric vehicle plug-in recharging, vehicle to grid power generation. That's where electric vehicle regenerative acceleration equipped vehicle is capable of powering into the grid and discharging its stored energy into the grid. And if we have time, we'll get into how and why electromagnetically induced magnetic fields are a form of energy which is created, and what we're doing is we are using the magnetic fields that are created in a generator and a transformer in beneficial ways rather than parasitic ways. Electric vehicle regenerative braking is caused by the magnetic fields that are created inside the generator. They basically rob the electric vehicle of kinetic energy, and what we do, because of the load current delay, we're able to reverse regenerative braking, create regenerative acceleration, use the same magnetic fields in a beneficial way. And that's the essence of the ReGenX generator and the bitoroid transformer. We use induced magnetic field energy in a novel way, and in a novel and beneficial way. Currently it's used in a parasitic way, and so we're reversing that entire paradigm. And the one thing that's not on here, if we have time, what I'll do is explain, especially to you, why and how the ReGenX generator does what it does. During the demonstration, I'm going to be introducing some terms like flux harvesting, which is it's a term that applies to the innovation, and the other one is a critical minimum frequency. So I'll show that on this prototype over here. The critical minimum frequency for the ReGenX coil, above the critical minimum frequency of operation, you are in regenerative acceleration mode, and below it, you are in conventional generator operation. So by the time we're done, you'll be familiar with that, and then I will explain what happens to the coil when it transitions from operating below the critical minimum frequency to above. And we're good.